Good morning, students. In the last class we discussed about the different type of sequential statements, and next we are supposed to study about the another type of sequential statement that we are using in process statement, that is case statement. So in that case statement, first we are going to look at the syntax for that particular case. So it starts with a keyword case, then after that it's having the expression. Okay, so within that particular expression it is going to evaluate that particular expression, and finally we can able to get a value. So that is what going to happen within that particular expression. And next is, then after that when. Okay, that is a keyword. Then choices. So whatever the possible choices for that particular expression, those we can able to describe over here. And next to that equals to greater than sequential statements. So like this, okay, same statement will repeat multiple times because of that, and so on. When choices equals to greater than sequential statements, and finally we are supposed to close that particular case statement by means of considering the end case. Okay, whenever you started a case, obviously you are supposed to close that particular case by means of using the end case statement. So that is how it seems to be. Then how it is going to execute, let me explain. First it is going to evaluate the expression. By means of that, so you can able to get a certain value. So that value will be verified with all these choices. Okay, whatever choices we mentioned over there, that value is going to verify. If that particular one matches with any one of the choice, then obviously that sequential statements are going to execute. If this particular value matches with this particular choice, then obviously these are all the sequential statements are going to execute. Like that, with whatever choice it matches, those sequential statements are going to execute. And while coming for this, as we discussed previously, whenever we are mentioning choices, all these choices must be mutually exclusive to each other. No two choices should match. Okay, that is the thing we are supposed to take care. And whatever the possible values that we have, possible combinations, outputs of that particular expression, all those must be covered. So whatever possible choices we have for that particular one, all those must be covered, and all those choices must be mutually exclusive. And within a single statement also, you can also able to describe the multiple choices. Okay, here we have option that choice may be a single one or multiple choices you can able to describe. If it is a single one, then okay. If we consider the multiple choices, then obviously those choices must be separated by with a vertical bar symbol. Okay, vertical bar, which is going to indicate the R symbol. Vertical R is going to represent the R. So that one you can able to use if you want to describe the multiple choices in a single statement, as we discussed previously. Then after that, whatever value matches, then here sequential statements are going to present. So on the right hand side, it may consist of single or multiple statements. So based on the matching of that particular choice, those sequential statements are going to execute. So that is how the syntax seems to be. And finally, while coming for this particular final choice, we can able to describe the others. By means of mentioning this particular last choice as others, we can able to cover, so what are all the choices, so till now we didn't cover, all those will be covered in that particular others. So because of that, so in case the last choice must be others. Okay, as I explained in the previous class, suppose in the last class I mentioned that if I consider a bit, or if I consider an array of 2 bits, that means where it consists of 2, that array consists of 2 elements. If that is the case, and the type that we mentioned is std_logic_vector, then obviously std_logic, that particular one consists of total 9 values. We can able to assign any one of those 9 values. So if it is a 2-bit, then obviously total possible combinations are 9 square, 81 combinations are possible. Okay, so because of that, so all those you can't able to describe over here. So whatever required, those choices you are supposed to mention, and finally in the final choice, if you mention others, then obviously whatever the choices we didn't cover it in those 81, all those we can able to cover over here. By means of that, So the last choice must be a others. Okay, if that case is true, then obviously these are all the sequential statements are going to execute. And finally, at any case, we are supposed to close that particular case statement by means of considering an end case. Okay, whenever case is there, so must and should, we are supposed to close that particular one by means of using the keyword end case. So this is how the syntax seems to be for case statement. Using of this particular case statement, next our intention is to design a prime number detector. Okay, so that is what, once again I consider the same example. Okay, using of this particular one, next we are supposed to realize a program for the prime number detector. So this is how it seems to be. Anyway, entity declaration part seems to be same irrespective of whatever description style. In that regard, we didn't consider it. Okay, it mainly going to differentiate with respect to architecture definition. So in that regard, here also I considered that particular architecture definition. So it starts with the keyword architecture, then architecture name. So this is the prime, so that we considered, and of entity name. So this is the entity name we mentioned over there. Then is a keyword. Then after that begin, and before architecture and begin, if necessary, we can able to describe any internal signals, but here we are not going to describing, we are not using any internal signals. So in that regard, no need to mention any signals over there. And after that begin, so the concurrent statements we are supposed to mention within the architecture body. So in behavioral description style, the concurrent statement that we are using is process. And within brackets we are going to represent the sensitivity list, that is nothing but inputs of that particular prime number detector, which is n. Okay, n is an array we declared because of that n that I mentioned. Then after that begin. Before begin also, if there is any internally we are using any variables, then we are supposed to declare over there. Okay, but anyway here we are not required any variables. So in that regard, anyway, first skip that particular variable declaration part. After writing the process body, then so if there is necessary, then we are supposed to declare that particular variable declaration. It seems to be easy. So in that regard, after writing process body, if there is any necessary, then we are supposed to declare that particular variable state declarations. Okay. So because of that, first I started the process body begin. Then after that, so as I mentioned, syntax for the case statement, which starts with the keyword case. So first case. Then here we are supposed to mention the expression. So what here I consider is, so because of coming to here, actually I am supposed to mention the inputs. Okay, that n itself. If I mention that particular one, based on that particular one, I am going to define the functionality, because while coming for behavior, by means of knowing the truth table, you can able to describe the functionality. So in that regard, so what is the truth table? If the input is 1, 2, 3, 5, 7, 11, 13, then obviously that particular prime number detector output f must be 1. For all remaining cases, output f becomes 0. So that is what the truth table it consists of. But here all those combinations in binary form, because instead of this particular one, I am supposed to represent 4 bits. If I want to represent in terms of binary. So like that, instead of all these integers, we are supposed to represent with 4 binary bits. So it seems to be somewhat complex. So in that regard, to overcome that particular complexity, here also what we consider is, here we developed a function. That function name itself, convert underscore integer. So and within bracket formal parameters that we mentioned. So what that particular function will do is, so actually for that we are supposed to write a program. So where we mentioned within that particular function, it is going to convert std underscore logic underscore vector into an integer. That is nothing but in a simple way you can able to say that it's going to convert binary to integer. So that's what we are supposed to write that particular function. But at present I am not going to discuss how to write that particular function declaration. But instead of that, here I am assuming that, so here I call that particular function which is conversion of into integer from std underscore logic underscore vector. So in that regard, the input for this particular one must be input itself. Okay, prime number detector input, which is n0, n1, n2, n3, which is an array. That is what we are supposed to apply as input for that particular function. Then it will take that binary form and it is going to convert it into integer, and finally it will return back to that particular value. So in place of wherever we represented that particular function. So because of that, by means of mentioning this particular case, what happens? Okay, expression what happens? Function. Okay, this particular value is going to consider and that must be converted into integer. That value will be written over here. Okay, by means of that evaluating that particular function, you can able to get a certain value. Then after that, then when? So because of here we converted that binary into integer. Because of that, while I am writing choices, instead of a binary form, I can able to consider the integer form. So by means of that, it seems to be easy for us to write the program in that regard only. Here we call that particular function. But before executing this particular program, so we must execute this particular function. Where that particular function operation is, where it is going to convert the binary form into integer form. That is what? std_logic_vector, that is the type we assign for that particular signal n. That one we are converting into integer type. Okay, that functionality only it is going to perform. Okay, here we are not discussing that particular one, just we are assuming that that function already written previously and executed. So because of that, whenever we use this particular function, obviously it will take the binary and give output as integer form. Okay, so because of that, next when choices. First here I mentioned the choice as 1. Okay, anyway here I got the integer value, with that it is going to compare. Because of that, here I can able to return the integer values instead of binary. So first one is 1. If it is true, if this particular value matches with this, then obviously this sequential statement is going to execute. So that is f assigned a value of 1. Whenever you mention binary, okay, if it is a single bit, then obviously you have to put in single quotes. Okay, if it is multi-bit, more than one bit, within double quotes you are supposed to place. So because of that, here 1 single bit, no, single quotes we are supposed to indicate. So when 1 equals to greater than f less than or equals to 1. Okay, then after that, so second combination, when 2, if this particular okay, so value is 2, then in this particular case also, that is the sequential statement it is going to execute. Else, when if the value is either 3 or 5 or 7 or 11 or 13, for all these combinations, so this is the sequential statement is going to execute. F less than or equals to 1. Okay, because of all these are all prime numbers, so whenever anyone becomes true, obviously, so f value will be assigned it as 1. Okay, instead of writing all these three, combinedly all these you can able to describe in a single statement as well. Okay, but for the better understanding purpose, here I divided all those. So even you can able to mention instead of these three statement in a single statement also you can able to describe by means of mentioning such as 1 or 2 or 3 or 5 or 7 or 11 or 13 or equals to greater than f less than or equals to 1. By means of that, using of single when also you can able to complete these three statements. Okay, but anyway, for the better explanation purpose, here I divided such as like that. Single choice also we can able to derive, or multiple choice also we can able to derive at a time. Okay, then after that, obviously the last choice must be when others. Okay, so by means of mentioning others, it is going to cover remaining all combinations, whatever present over there, all those combinations it is going to cover. Okay, so how many combinations actually it consists of? So you may think that because of 4 inputs it consists of 2 power 4 only 16, but that is not true. Okay, so as per our thinking, because of it consists of 4 inputs, n0, n1, n2, n3. Total different input combinations possibility is 2 power 4 16, but that is not the true, because there we considered binary. So because of binary means zeros and ones, because of that only we are mentioning it as 2 power 4. But here n we are mentioning the type as std_logic_vector, where std_logic_vector, where it consists of 9 different values. So other than 0, 1, you can also describe remaining 7 values as well. By means of the total, how many combinations? 9 power, anyway array size is 4. 9 power 4 combinations actually it consists of. So in this particular other than these 7, okay, 5 plus 2, 7, other than these 7, remaining all combination of 9 power 4 will be covered by means of this particular other statement. So in that regard, so we must mention last choice as others. Then only it can able to cover so all the remaining combinations. In this particular case, total 9 power 4 combinations are possible. How I mentioned this particular 9 is, anyway, as you know that by means of 4 inputs, okay, N0, N1, N2, N3, total possible input combination is 2 power 4. Why we are mentioning below 2 is, if you mentioning, okay, if you are assigning values for them as bits, 0 or 1. So because of that only 2 possibilities there we are considering. So in that regard 2 power 4. But in this particular case, N we describe it type as std_like_vector. Vector. Because of that in std_underscore logic total 9 possible values are there. Other than 0, 1, X undefined, week 0, week 1. Okay. So all those are all there other than that particular 2. So in that regard total 9 possibilities are there now. So because of that 9 to the power of size of that particular array which is 4 bit. So because of that 9 power 4 combinations are possible. So in that regard if you mention others other than these 7, remaining all which are present in that particular 9 power 4 will be covered over here for all those input combinations. So these are all the sequential statements are going to execute, which is f less than or equals to 0. Okay. Anyway, these are all the prime numbers within 0 to 15. For all these we mentioned f must be assigned a value of 1. While coming for all other cases, f must be assigned a value of 0. So that is how so we can able to write a program by means of converting that particular binary into integer. In a simple way we can able to describe the functionality. That is the advantage. So in that regard only here we call that particular function where the functionality of that particular one is going to convert binary form into integer. Or that particular n we declared a type of std_like_vector converting that particular std_like_vector into a type of integer. So that's what converting it. So this much easy way you can able to describe the functionality. Directly you can able to consider the integer values instead of representing in binary form. Okay. So that is what the advantage. And after completing all the possible choices for that particular expression, then we are supposed to close that particular case first. So in that regard, first we are supposed to mention AND case. Then after that, here begin is there. That must be completed because of that AND process. Okay, this begin is for process. We are supposed to terminate it because of the by means of considering the AND process. Then after that, we are supposed to close the architecture body. By means for this particular begin also, we are supposed to close with an AND. So that is one more AND primate underscore architecture name, which is AND architecture name. And one more thing is, as I mentioned over here, so in between process and begin, if there is necessary, we are supposed to declare variable declaration. So if you look at this particular process body, so if you mention any new variable, okay, then we are supposed to declare over there. But here what is the variable we consider? Only f. Other than that, so we didn't mention any other variables. And also here n is there. N and f, that's it. So these two, n and f, we already declared in entity declaration part. So in that regard, no need to declare once again within the process. Okay, if you declare over there, directly you can able to use within that particular process. So because of that, here there is no variable statement. Additional variable statements are not required. Variable declaration is. Okay. So in that regard, no statement. Variable statement is not present over there. Variable declaration part not required. So this is how. So the program for that particular prime number detector by means of using the case statement in behavioral description style, that too in VHDL. Okay. Anyway, thank you. Thank you very much.